In this video, we're going to look at polar coordinates and plotting points in the polar coordinate plane. So the polar coordinate system is just a plane which has a point O, which we refer to as the pole. So this is my pole, and then we have a ray from O, which is called the polar axis. So my polar axis would be here. Typically, the polar axis is sort of in the same place on the coordinate plane as the positive x-axis. So when we plot a point in the polar coordinate system, it consists of an r value, which is the distance from the pole O to your given point P, and it has a value theta, which is the directed angle of rotation. So if we kind of go back to our rectangular coordinate system or the Cartesian coordinate system, we would plot points x, y, and so x would be our left-right distance and y would be our up and down distance. So now when we plot a point in the polar coordinate system, that point is going to be r theta. So again, this is going to tell me how far I am away from the origin, and then also my rotation around that origin. All right, when we're looking at a polar grid system and we're going to plot points, it's going to look something like this. Now, polar grids will have different numbers of divisions around the circle, so you're going to have to be careful with that. Most of the ones I give you will look like this, so we'll kind of use this as our standard. So what I want you to think about is, okay, if there's 1, 2, 3, 4, 5, 6 regions in this first quadrant here, then 90 degrees divided by 6 gives me 15 degrees. So that means each of these is 15 degrees. So this is 15, this is 30, this is 45, etc. If we're working in radian measure, remember we're just looking at the first quadrant. The first quadrant is pi over 2, and we divide that by 6, then that's going to give us pi over 2 times 1/6, which is pi over 12. So if I'm working in radians, this is 1 pi over 12, this is 2 pi over 12, which will be pi over 6, 3 pi over 12, which will be pi over 4, and again, etc. So when you're going to graph a point, you want to look at your grid system and how many divisions you have around your circle and make sure you know what kind of rotation each of those divisions is representing. Okay, so if we want to plot some points in the polar grid, we're going to plot this first point here, 2 pi over 3. So remember the first point here, this is my r value, and then my theta value is pi over 3. So what we want to do first is just kind of mark our axis along here. So I'm just going to mark this 1, 2, 3, 4, 5, etc. You can set this x-axis up however you would like, just like you could in a regular rectangular or Cartesian system. Each tick mark can be 1, 10, whatever. So we're just plotting some very general points here, so I'm just going to use the integral values. So if I'm going to plot this P point here, this says 2, so I'm going to start here and I'm going to come out 2 units, and then I have to rotate pi over 3. I like to write my points using 12 in the denominator of my radian values, so I'm just going to rewrite this. So if I'm going to write this with a denominator of 12, I'm going to multiply by 4. 3 times 4 gives me 12, so then this is going to be 4 pi over 12. So then that tells me that I'm going to rotate 4 sections. So I come out here to 2, and then I go 1, 2, 3, 4, so 4 pi over 12, which is pi over 3. So then this is the point P, which is 2 pi over 3. So my next point here, Q, so again, I'm going to rewrite this as -1. Again, I want this to be 12 in the denominator, so I'm going to multiply here. I need to multiply both by 3, so it's going to be -9 pi over 12. So again, I'm going to start here at the origin, and then I want to go -1, so I'm going to come back this way to the left, and then I have to rotate 9 sections. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to end up here at Q, which is the point -1, 3 pi over 4. Finally, here I have this point R, which is 3, -45 degrees. So I'm going to come out to 3. So 1, 2, 3. And now I have to do a negative rotation. So remember, I'm going to go clockwise instead of counterclockwise. And I'm going to go 45 degrees. Remembering each of these is 15 degrees. So 15, 30, 45. So I'm going to end up here. So this is R, which is 3, -45 degrees. All right, so we've got a couple more examples here. So this first one, S, is 4 and then -pi over 3. So again, I'm just going to mark these real quick here. Okay, so we're going to plot for negative pi over 3. So again, I'm going to rewrite this for negative 4 pi over 12. So multiplying both by 4, so I can get 12 in the denominator. So I'm going to come out 4 units, 1, 2, 3, 4. So I'm going to come out here, and then I'm rotating in the negative direction, so I'm going to go clockwise. So I'm going to go 4 this way, and here I get point S, which is 4 negative pi over 3. Next, we're going to do point T. Point T already has 12 in the denominator, so I don't have to rewrite it. This one is negative 3, so again, I'm going to come out 1, 2, 3 to the left, and then we're going to rotate 13 pi over 12. So remember here I'm going counterclockwise because that's a positive rotation, so I'm going to count 13 units. Point T, which is negative 3, 13 pi over 12. And then lastly, I have U, which is negative 5, negative 4 pi over 3, so we're going to come out to negative 5, and then we're going to rotate, let's rewrite this. So this is negative 5, negative 16 pi over 12. So we're going to come out to negative 5, and then we're going to rotate 16 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'll end up here, and this is U, which is negative 5, negative 4 pi over 3. So a point in the polar plane really has an infinite amount of coordinates that will get you to that point. So there are multiple different points that will land us at the same particular place. So in order to find those points, we can use coterminal rotations, and we can also use positive and negative R values. So let's say we just have some general point right here, and this is R theta. So I'm going to get to that point by coming from the origin. I'm going to come out R units, which puts me on this circle here where the point is located. And then I'm going to rotate theta. So this is the rotation of theta. Okay, so I could also get to that same point by coming out to R, and then instead of rotating theta, I can rotate a coterminal rotation to that. The initial point we started with was R theta, and then this second one that I came up with is R, and then this would be theta minus a whole circle, so we'll say minus 2 pi, or R is theta minus 360 degrees. So I would get this by coming out to the same R value but doing a negative rotation. I could also get to that same point by doing negative R. So if I came out negative R out to here, and then we could rotate in the counterclockwise direction, which would be all the way around here, so half of a circle, and then back to where I started from. So negative R, and then we could rotate a half circle plus that original angle that we had there. Or if that was in degrees, we would say negative R and then 180 plus the original angle of rotation. I could also get there by doing negative R, so coming out here again, and then rotating just up to this point in a negative rotation. So it's the original angle minus a half circle. So we could do theta minus pi here, or negative R, and then theta minus 180 degrees. Then I could also add complete rotations around to that, so we could get an infinite amount of rotations and points by using coterminal angles. Okay, so here we want to find 3 other polar coordinates for the point 3 pi over 3. So first of all, let's visualize where this is. So this would be 3, and then if I rewrite this, this would be 3, 4 pi over 12. So then I can rotate from here 4 sections, which would put me here. So I came out to 3, and then I rotated in the positive direction, and we have 3 pi over 3. So if I start here and I come out again to positive 3, then I want to rotate in the negative direction, clockwise around to that. So remember, that would be the rest of the circle. So in order to find that angle, I'm going to take the pi over 3 minus 2 pi, which is going to give us pi over 3 minus 6 pi over 3, which will give us negative 5 pi over 3. So another set of coordinates, which would get me to the same point, would be 3, negative 5 pi over 3. So instead of going in the positive direction, if we start at the pole and we go in the negative direction, so I'm going to come out to negative 3, and then again I'm going to rotate in the positive angle. So I'm going to rotate a half circle, which would be pi, and then back to that point. So in order to get this rotation, I'm going to do pi plus the pi over 3. So pi over 3 plus pi is going to give me 4 pi over 3. So then I could say negative 3, positive 4 pi over 3. And then again, if I come out to negative 3, then I could rotate in this direction, which would be a negative rotation because I'm moving clockwise. And this is pi minus the original angle of pi over 3. So if we do pi over 3 minus pi, that's going to give us negative 2 pi over 3. So we could do negative 3, negative 2 pi over 3. So then I've got 3 other sets of polar coordinates. Now again, we could take any of these values that we had here and just add a whole circle to that angle, and that would give us another set of values. So there are infinitely many. So if we want to find all polar coordinates, so just like when we solved trig equations, we had infinitely many answers and we wrote some expressions that would describe all of those. We want to write some expressions that would describe all of these as well. So if I have some point r theta, then all other polar coordinates come from keeping r the same value, so don't change the sign on it, and then we can add any number of whole circles, so 2 pi n. Or we can change the sign on r, and then we have theta plus 2n plus 1 pi. So let's simplify that for a minute. If we have negative r theta plus 2n plus 1 pi. So here I'm going to distribute the pi into the parenthesis here. So we're going to go plus 2 pi n plus pi. So really this is our original theta plus pi, which is a half circle, plus 2 pi n. So we can evaluate this part here, whatever our angle was, we can add the half circle to it, which is pi. So we've got this one, and then we've got r is theta plus 2 pi n. If we're working in degrees, this would be r, and then theta plus 360 degrees n. And then the other one would be negative r, and then it would be theta plus a half circle here, remember, would be 180 degrees plus 360 degrees n. So really it's just keeping the r value as it was given to you, and then writing your theta with a whole circle times n, or changing the sign of your r, and then in that case you're going to add a half circle to your theta value and then write plus a whole circle n onto that. So we're going to write all polar coordinates for the point P to pi over 6. So again, I want to kind of visualize where that is first. So I've got 2, and then I'm going to write this. This is 2 pi over 12. So here I'm going to come out to 2, and then I'm just going to rotate 2 sections, which is 2 pi over 12 or pi over 6. So this is P, and this is the point 2 pi over 6. So I want to write all polar coordinates for that. So remember what we're going to do is we're going to say P is 2 and then pi over 6 plus a whole circle n, so 2 pi n. Or we could write negative 2, and then we're going to do pi over 6 plus pi, so a half circle. And we're going to simplify that, plus 2 pi n. So then this is going to give me negative 2, and then this would give me 7 pi over 6 plus 2 pi n. And those are my 2 expressions that give me all of the polar coordinates for that point. Similar question, but we're working in degrees here. So we're going to plot this point. So we're going to plot, this is negative 3, negative 2, so we're going to be a halfway here, and then we're going to rotate 50 degrees. So remember, this is counterclockwise because that's a positive rotation, and these are 15-degree segments. So this is 15, 30, 45, this would be 60. So I'm just going to approximate what would be about here. So this is Q, negative 2.5, 50 degrees. So then I'm going to write negative 2.5, so I'm going to leave r the way it was given to me, and then I'm just going to write 50 degrees plus a whole circle, which is 360 degrees n. And then my second one, I'm going to change the sign on r, so now it's positive 2.5, 50 degrees plus a half circle, so 180 degrees plus 360 n. So again, I'm going to simplify that, so this is 2.5, 50 and 180 is going to give me 230 degrees plus 360 degrees n. So those two expressions give me all polar coordinates for that same point.